Okay, folks, lesson 32 is about polynomial equations. In this lesson, we're going to be given zeros, roots, solutions, x-intercepts. That's all the same thing. And we're going to be asked to either solve the polynomial or write a polynomial, given the roots. You will want your calculator for one of the examples, so please have one ready. And then let's get started. Example 1. Find a cubic equation with integer coefficients given the roots are 2 and 3 minus I. So let's go back to the words, right? Cubic equation means that we're dealing with an x cubed, right? X cubed. Integer coefficients means that we're dealing with whole numbers, no fractions. And then roots that are 2 and 3i indicate that they've given us some of the x-intercepts, but I have to be careful. They've only given us 2, and my goal is to find a cubic equation. So here's what I'm going to do. I'm going to list my givens. So I have x is equal to 2, and I have x is equal to 3 minus I. Now, in our past, when we saw a solution that said something like 3 minus I, we also had the conjugate of it, which was 3 plus I. This is an implied root that is not mentioned. So as we solve this, I'm going to show you what I mean. So my goal is to go from roots to factors. So to get to a factor, I have to make it equal 0. So we have x minus 2 equals 0. So that indicates that x minus 2 is a factor. Now when I look over here, I'm going to do the same thing, move the whole real numbers. So we have x minus 3 equals negative I. But from here, what do you do? Because I need that I to say a number. I don't want imaginaries in my factors. So what I'm going to have to do here is I'm going to have to square both sides. When I square both sides, remember what I squared is, right? Well, if I is equal to the square root of negative 1, then I squared is equal to negative 1. So we're going to expand x minus 3 squared, and we get x squared minus 6x plus 9, which equals negative 1. Because, again, I squared or negative I squared is the same thing as negative 1. Now make that say 0, because that's what it means to be a factor. So we have x squared minus 6x plus 10 equals 0, and there is a factor. Now let's talk about that factor. A factor says x squared. So doesn't that mean that factor contains 2 zeros? Sure enough, it does. So with that, we have x squared minus 6x plus 10, and we need to multiply it with x minus 2 to get our p of x cubic equation. So our goal is to get our cubic equation. X minus 2 times x squared minus 6x plus 10. When I multiply this out, I'm going to get x cubed minus 6x squared plus 10x minus 2x squared plus 12x minus 20. Combine your like terms. X cubed minus 8x squared plus 22x minus 20, and this is equal to our polynomial p of x. Example 1, done. Folks, I want you to take note of what we did here, right? This is very important. We went from 1, 0 to a factor containing 2 as the degree, which indicates that we have that implied 0 within there. Implied 0, the conjugate. Okay, example 2. Example 2 says solve, so let's remind ourselves real quick what solve means. Solve means I'm going to find the x-intercepts of this polynomial. Now the polynomial is x to the 4th plus 4x cubed plus 4x minus 1 equals 0. Now they've given me a root. So again, I have a solution. So I'm gonna start with, here are my zeros, right? Here are the zeros that I need to find, right? I need to find 4 zeros. Now again, how did I know I was finding 4 zeros? Remind yourself. I'm finding 4 zeros because that's right, the degree of this polynomial that they've given me is 4, which would indicate that there are 4 different zeros that I need. It seems that they've given me a root. Now let's remind ourselves, x is equal to negative 2 minus root 5. Now this is similar to that 3 minus I root because it has this radical. So again, I'm going to move the real number to the x. So we have x plus 2 equals negative root 5. And not that negative root 5 isn't a real number, so I should clarify that. But this looks similar to that I setup, and this is how you're going to want to do this step. You always move that integer number to the x side, leaving the radical or the imaginary on the right-hand side. Then you're going to take that operation and square both sides. When you do that, you're actually getting that conjugated root. So we'll talk about that in a few minutes. So then, from here, expand that binomial. So we have x squared plus 4x plus 4 is equal to, now what's negative square root of 5 times negative square root of 5? Well, that's positive 5. Again, make that say 0 to equal a factor. X squared plus 4x minus 1 equals 0. And sure enough, that is our factor. Okay, so here's our factor. Now, that factor, again, contains the conjugate of the 0 that they gave me. So they gave me the 0, negative 2 minus root 5. But what's the conjugate? Well, negative 2 plus root 5. That indicates that I have 2 of my 4 zeros. Now from here, that is a quadratic, and this is a quartic. So how am I going to find the other factor? Well, that's right, we're going to long division. So we have x squared plus 4x minus 1, and we're dividing x to the 4th plus 4x cubed plus 0x squared plus 4x minus 1. From here, ask yourself, what times x squared is x to the 4th? Well, that's x squared. So multiply x squared to each term, so you get x to the 4th plus 4x cubed minus x squared. Negate all the terms and then simplify what you have. I see that we have x squared plus 4x minus 1, and to get that, you would then just multiply the divisor by positive 1. That's going to give us x squared plus 4x minus 1, and then subtract away what you see. When you do, you're left with a remainder of 0. Now, go back to the question. The question says solve. So we have yet to solve. What we've done now is find the second factor. Now that factor is x squared plus 1. If I need to solve, then make that factor equal 0 and solve appropriately. So there's the factor equal to 0. Solving appropriately, I get x squared is equal to negative 1, square root both sides, so x is equal to plus or minus I. That is how many roots? 2. Add that to your list of already 2 roots, and sure enough, you have 4 solutions listed as your zeros. Example 2 is done. Heading to example 3. So this is where we're going to grab that graphing calculator. So when I get my graphing calculator, I'm going to plug into y equals this function. 2x to the 5th plus 5x to the 4th minus 8x cubed minus 14x squared plus 6x plus 9. Then I'd like you to go to the graph of it. Notice the graph shape. And if you look at your graph, right, you'll see that we have 4 times that it crosses the x-axis, where one of those zeros looks to be a double root. Now let's go to the table, second graph. And when I look at the table, I start to see some zeros in my y1 column. I see that when I have x is negative 3, I have a 0. When I have x is negative 1, I have another 0. And when I have x is positive 1, I have a third 0. Now again, go back to your graph and try to find which one of those 3 x values has the double root. Good. I'm giving you some time. Hopefully you agree that your double root is right there. negative 1. So I'm going to actually write negative 1 twice to help me understand that that is a double root. Okay, so that means that I have 4 of my 5 zeros, and I have to go find the 5th. Now, why did I know I needed to find the zeros? Because, again, it said the phrase solve. Solve indicates go find the x-intercepts. Okay, I have a degree of 5. I have a leading coefficient of a positive. So I know that my graph, I've already looked at my graph, I know what it looks like. So what I'm going to do now is, because I have 4 of the 5 zeros, I'm going to divide them out. So I'm going to set up my synthetic division with negative 3 on the outside, creating my synthetic to divide. So we have 2x to the 5th, 5x to the 4th, negative 8x cubed, negative 14x squared, 6x, 9. Use your synthetic method and solve. So step 1, drop. 2 times negative 3, negative 6. Negative 1 is the sum. Positive 3 is the product. Negative 5 is the sum. Positive 15 is the product. Positive 1 is the sum. Negative 3 is the product. 3 is the sum. Negative 9 is the product. 0 is the remainder, as it should be, since it is a 0 on my graph. I'm going to then divide out the next 0, which is negative 1. So here we go. We have negative 1. We're going to divide that out. So step 1, drop it. We have 2 times negative 1. The product is negative 2. The sum is negative 3. The product is positive 3. The sum is negative 2. The product is positive 2. The sum is 3. The product is negative 3. The sum is 0. And again, we're going to divide out that negative 1. Remember, negative 1 was our double root. So here goes the next one. Step 1, drop. So we have 2. Oh, maybe I should write negative 1 on the outside. Good job. Okay, 2 times negative 1. The product is negative 2. The sum is going to be negative 5. Negative 5 times 1 is 5. The sum is going to be 3. The product is negative 3. The remainder is 0. Last but not least, we have our 4th 0 to divide out. That 0 is positive 1. So then, we're left with 2 drops. So 2 times 1 is 2. 5 is negative 3. The product is negative 3. The sum is 0. So we're left with a factor, right, of 2x minus 3, and this is equal to 0. So now solve that for your last 0. Well, don't you get that you get 2x is equal to 3, so x is 3 halves. And that's what goes up here, 3 halves. Okay, so why is that important? Well, this here would be your answers listed in solution set, right? But when it gets important is when we ask you this next question. So for 3b, we have, using that same polynomial, state the intervals where p of x is greater than 0. Okay, hold on. So now Mr. Henson and Ms. Weissmiller would like us to take this and use a sign test. Remember, this is indicating we need a sign graph. So I'm going to set up my sign graph. I'm going to start here accordingly. We have our graph. Now what's next is we need to list our zeros from least to greatest. So we know one zero is happening at negative 3. We know another 0 is happening at negative 1. A third 0 is happening at positive 1. And a fourth 0 is happening at 1.5, also known as 3 halves. Now, what we're being asked to do is find out where this polynomial is greater than 0. So that's right, we have to set up our test values, right? So our test values, we practiced this again last semester. So I'm going to do a test value out here. I'm going to say that let x equal negative 100. Negative 100 is within this domain. So when I plug in a negative 100 to all of these factors, and I'm just going to plug in a number and write negative or positive. So negative 100 times 2 is a really big negative number. Okay. Negative 100 minus 1 is also a negative number. Negative 100 plus 1, okay, so negative 99. squared makes a positive number, and then negative 100 plus 3 is a negative number. So now what's the product of negative times positive times negative? Well, that's negative. So that means that this is in the negative realm. Now, back in the past when we did this, a lot of the times we had alternating signs. But we have to be careful because we have a different multiplicity on one of these factors. So it's going to be slightly different. So let's do a new test value. Let's let x equal negative 2 because negative 2 falls within this section. Negative 2, good. Plug in negative 2 to these and let's write positives or negatives. So negative 2 times 2, oh, that's negative 4 minus 3 more. Oh, that's a negative number. Negative 2 minus 1, oh, that's a negative number. Negative 2 plus 1 is negative 1, but squared is positive. Negative 2 plus 3, oh, that's a positive. So when I take the product of those four signs, we have negative times negative is positive, times 2 more positives makes positive. So this is going to be in the positive section of our graph. When x is between negative 3 and negative 1, we know that the graph will be above the x-axis. Now, going to the next region. I'm going to pick a test value in here. I'm going to say let x equal 0, because again, x is somewhere between, 0 is somewhere between negative 1 and 1. So plug in a 0 to each of these factors, and let's see what we get. 0 times 2 is 0, but negative 3 means there's a negative. 0 minus 1 means there's a negative 1. 0 plus 1, quantity squared, means we're dealing with a positive. And then 0 plus 3 means we're also dealing with a positive. From here, this looks similar to the last region. Negative times negative is positive. Positive times all positives makes a positive. So notice what happens here. The graph is still in the positive realm for that x value. Okay, on to the next section. So the test value will be let x equal to, well, that's going to be fun, right? We have something between 1 and 1/2. So what about 1 1/4? So that'd be 5/4, right? That's 1 1/4 is between those two values. Okay, now this might be a little more tricky, so let's go slower. We have 5/4 replacing all of these x's. So when I do 2 times 5/4, I get 5/2 minus 3, which is really like minus 6/2. So 5/2 minus 6/2 makes a negative number. 5/4 minus 4/4 makes a positive number. 5/4 plus 1 makes a bigger positive number, and when I square it, it's a positive number. And then 5/4 plus 3 is going to be a positive number. When I take the product of those four symbols, I'm going to be left with a negative. So this drops my region back down low. Okay, last but not least, the last test value of this whole beautiful thing. We're going to do the test value, and we're going to let x equal positive 100. Okay, so when x is positive 100, go back to your factored form. We have 200 minus 3 is going to be a really big positive number. 100 minus 1 is still a positive number. 100 plus 1 squared is a positive number. 100 plus 3 is a positive number. When I take the product of all of those symbols, I'm back in the positives. Now that makes sense because look at it. We have a 5th degree polynomial. So the end behaviors, the very ends of it, right? The severe ends of this. This end and this end, right? The end behavior should be opposites because we're dealing with an odd exponent, right? That exponent is 5. That's an odd number, so opposite end behavior. Because we're dealing with a coefficient that is a positive, right? A positive coefficient, that indicates that the right-hand side behavior should be positive. So this sign graph ends up matching what our prediction of our graph would be. What this allows us to do, though, is determine what's happening in the middle. Okay, so example 4, last example of today. Example 4 says we're supposed to write a polynomial function, p of x, as a product of factors with zeros of -2, 3 plus 2i, 1, and it has a y-intercept of 39. Now let's think back to polynomial functions, right? They have an a value, a leading coefficient. So did this problem provide us with a leading coefficient? The answer is no. So our task is to utilize the given information they provided, right? We know that x is equal to -2. We know that x is equal to 3 plus 2i. We also have to be careful to remember that there's a conjugate 0 in there, so that's going to be a quadratic factor. And then we have one more 0, x is equal to 1. We do know a coordinate, right? We know that when p of 0 is entered, we get the value of 39, right? And this notation will be used on the homework a lot, so remember that homework. Remember the notation, right? P of 0 is 39. 0 is the x value, where 39 is the y value. If I wrote it as a coordinate, it would look like this. So my goal is to set up the factored form of this, utilize this x and y value to then solve for a sub n, right? My goal is to solve for a sub n. So here we go. Let's find our factors. This first factor, if you add 2 to both sides, you'd get x plus 2 is equal to 0. The second one, we have to do some big math. So we have x minus 3 is equal to 2i. We then square both sides, and we get x squared minus 6x plus 9 equals, now 2 times 2 is 4, but I times I is -1, so we're left with -4. Set that factor equal to 0, and it's a factor, so we have x squared minus 6x plus 13 equals 0. And the last factor I see would be x minus 1 equals 0. Now from here, we have 1 factor, 2 factors, 3 factors. We're going to set up our polynomial functions. So we have p of x, right? P of x is equal to a sub n, which we don't know yet, times x plus 2 times x squared minus 6x plus 13 times x minus 1. Now we're going to use the x and y that we have. So we have the y value is 39. We have the x values are all 0. So I'm just going to replace all those x's with 0 and rewrite what I have. A sub n times 0 plus 2 times 0 squared minus 6 times 0 plus 13 times 0 minus 1. Well, that means I really have 39, which equals a sub n times 2 times 13 times -1. When I take that product, I'm left with 39 is equal to -26 a sub n. So a sub n is -3/2. So my final answer of this problem says that I would have p of x, which equals -3/2 times x plus 2 times x squared minus 6x plus 13 times x minus 1. And this is lesson 32, polynomial equations. Folks, good luck on the homework.